Hello, my name is Brian Trung, and I will be talking about cloud computing in a software engineering perspective.
In today's video, I will be explaining all the hype surrounding cloud computing, from all the risks that product managers and developers should be aware of, to why most tech companies have integrated a cloud system into their own software infrastructure.
What is cloud computing? Simply put, cloud computing is the delivery of computing services such as servers, storage, databases, networking, software, and analytics and intelligence over the internet, which is commonly referred to as the cloud, to offer faster innovation, flexible resources, and economic scalability. The typical standard for the business model of many companies that provide cloud computing services is to allow users to do a pay-as-you-go basis, like a membership fee where companies purchase only what their software developers need. Cloud computing services cover a vast range of options now, from the basics of storage, networking, and processing power to natural language processing and artificial intelligence, as well as standard office applications. Pretty much any service that doesn't require you to be physically close to the computer hardware that you're using can now be delivered via the cloud. The benefits behind organizations transitioning to cloud computing services include cost, agility, global scale, productivity, reliability, and security all allow software engineers to run their infrastructure more efficiently and allow their projects to scale as they implement new features and changes. The cloud has resulted in causing a huge innovation shift from the traditional way many companies think about software engineering applications in the industry.
I will now be talking about the three types of cloud services.
The three types of cloud services. This section is important because developers will need to explain to their product managers which type of service is necessary for their project to run efficiently so that the company can save money on cost. The cloud computing architecture contains three different layers that software developers can decide which is relevant towards implementing into their project and pay for the specific service needed. The three layers that engineers can use are infrastructure as a service, platform as a service, and software as a service, where each service provides a set of different tools that potential software engineers would use in the industry. The layers are split by the number of tools provided in each package, where the infrastructure as a service has the least amount of tools to the software as a service, which has the most features of the respective company's cloud computing product. In this slide, I will be discussing the types mentioned before. I made a graphic that sums up how the cloud computing architecture works. At the top is infrastructure as a service, because it is the most basic category of cloud computing services. With infrastructure as a service, you run IT infrastructure such as servers, virtual machines, storage networks, and operating systems from a cloud provider on a pay-to-go basis. IaaS quickly scales up and down with demand, letting you pay only for what you use. It helps you avoid the expense and complexity of buying and managing your own physical servers and other data center infrastructure. Each resource is offered as a separate service component, and you only need to rent a particular one for as long as you need it. This means future software engineers such as ourselves can use a cloud computing service provider. Most commonly popular one would be Azure, to manage our infrastructure while we purchase, install, configure, and manage our own software, operating systems, middleware, and applications. The next level down is platform as a service, that refers to cloud computing services that supply an on-demand environment for developing, testing, delivering, and managing software applications. PaaS is designed to make it easier for developers such as our classmates, or for example, our classmates to quickly create web or mobile apps without worrying about setting up or managing the underlying infrastructure of servers, storage, network, and databases needed for development. PaaS is designed to support the complete web application lifecycle and software process model of requirements, design, code, and unit test, integration and testing, and maintenance. Finally, the most complete category of cloud computing services is software as a service. Software as a service, also known as SaaS, allows users to connect to and use cloud-based apps over the internet. Common examples are email, calendaring, and office tools such as Microsoft Office 365 that we see in the industry today. SaaS provides a complete software solution that we can purchase on a pay-as-you-go basis from a cloud service provider. You rent the use of an app for your needs, and your users connect to it over the internet, usually with a web browser. All of the underlying infrastructure, middleware, app software, and app data are located in the service provider's data center. The service provider will then manage the hardware and software, and with the appropriate service agreement, will ensure the availability and security of the app as well as your data. SaaS allows your product demands to get quickly up and running with an app at minimal upfront cost. However, the true base layer of this cloud computing architecture would be the user's computing needs. A software engineer's computing needs are the last layer because of the way the cloud computing architecture works. As a user only needs to pay for what they need. They might only need infrastructure as a service for their project, or their project might demand the highest power cloud computing can provide with software as a service. Why switch to an integrated cloud-based system? Cloud computing incorporates many features and paradigms that offer many advantages to the principle of software engineering. There are two paradigms when it comes to using this on-demand computer system resource. The first would be resource outsourcing. Cloud computing delivers software resources to developers and software engineers through virtual portals. These developers and software engineers can implement these software services to their frameworks to help their application needs. The second paradigm would be the transition of technology management to these service providers. By integrating these cloud systems, developers are enabled to design applications through discovering different cloud resources. Cloud computing is designed to quickly provide services to users through scalable resources and load balancing on hardware. There are also many advantages to transitioning to a cloud-based system environment. In the industry, the cost is an important factor that most company product managers must think of. Cloud computing eliminates expenses on assembling and managing data centers to process their users' data. It also eliminates underlying costs like staff employment and land reservations for computer hardware. Agility is also another advantage of cloud computing. The cloud allows easy access to a span of different types of technologies to increase innovations and create practically anything imaginable. Software engineers are able to deploy technology resources in a matter of minutes. This enables features to be implemented faster than traditional deployment. In terms of the software process model, every step can be quickly executed while maintaining quality. This allows time for the freedom to experiment with different design inputs, test innovative ideas for customer satisfaction, and transform a company's business. The cloud's availability allows businesses to use resources in real time when they need it. In the end, cloud computing has become an affordable solution that gives nearly an unlimited amount of computing power for simplifying the designing and the deployment of a software engineer's needs. With reliable programming infrastructure, cloud app services, data storage, development tools, and open source software, cloud computing has supported the creative vision for innovating life-changing technologies that will revolutionize the future. Thank you for watching.